Hello and welcome to Maths by Anuj.
Next question. For a real number x, let box x denote the greatest integer function less than or equal to x. Let f from R to R be defined as fx is equal to 2x plus greatest integer x plus sin x cos x. Then f is 1 1 but not on 2 but not 1 1, both 1 1 and on 2, neither 1 1 nor on 2. So we have fx is equal to 2x plus box of x plus sin x cos x. Now I can write fx as 2x plus box x plus sin 2x by 2. Sin 2x by 2. Why? Because 2 sin x cos x is sin 2x. So I multiplied 2 and divided by 2. So this becomes sin 2x by 2. Okay. Now I have to define fx in intervals. This is why, because we have greatest integer of x here. So let us start from 0. So from 0 to 1. 0 to 1. Greatest integer of x will be 0. So our fx in that case will be 2x plus sin 2x by 2. 2x by sin 2x by 2. From 1 to 2. From 1 to 2, greatest integer x will be 1. So our function will be 2x plus 1 plus sin 2x by 2. From 2 to 3, we will have greatest integer of x to be 2. So this will be 2x plus 2 plus sin 2x by 2. So this is fx, and it can be defined in many other intervals, but I am considering for these three intervals. Now let us check for f dash x. So for f dash x in their particular intervals from 0 to 1, f dash x will be 2 plus cos 2x. Sin 2x differentiation is cos 2x into 2, and 2 gets cancelled, so 2 plus cos 2x. Similarly in this case also the differentiation will be 2 plus cos 2x. Differentiation of 1 will be 0 because it is a constant. From 0 to 1, this is from 1 to 2, and similarly it goes on. Hence for all the intervals the f dash x will be same. F dash x will be same. F dash x will remain same. Now we know that range of cos 2x is minus 1 to 1. So if I add 2, so it becomes 2 minus 1 less than equal to 2 plus cos 2x less than equal to 1 plus 2. So fx lies between 1 to 3. This shows that f dash x. So f dash x is positive for all x belongs to R. This implies that f of x is increasing function. Hence fx is 1 1. Fx is 1 1. Now I need to see whether it is onto or not. For onto I need to check whether the codomain is equal to R range. So in this case the codomain is R. Codomain is equal to R. So we have fx as equal to 2x plus greatest integer x plus sine 2x by 2. So I can see that domain for this function is R and we have x, so I can say that the range should also be R, but this is not the case because the range is not R because we have greatest integer function x here, which is discontinuous at integers. Greatest integer x is discontinuous at x is equal to I. For integers, greatest integer x is discontinuous. So I will check whether the function fx covers all the values of R. So let us check at x equal to 0. So LHL will be f of 0 minus is equal to 2 into 0 minus h, and we have limit h tends to 0 plus 0 minus box of x plus 1 by 2 sine 2 of 0 minus h. So now this is 0 minus means a value between minus 1 to 0. So this is minus 1 and this is 2 into 0 minus h, this will be 0 and 0 minus h will be minus 1. This will be minus 1 by 2 sine 2h. For 0 plus I will see this will be limit h tends to 0, 2 into 0 plus h plus 0 plus box plus 1 by 2 sine 2 of 0 plus h. So this will become 0, this will also become 0. So now we have sine 2h by 2. Now we see the function is not continuous, so because f dash 0 is not equal to f of 0 minus, hence it will not cover all the values of R, hence it is not onto. So the correct option is A, 1 1 but not 1 2. Next question. The maximum value of secant inverse of 7 minus 5 x square plus 3 upon 2 of 2 into x square plus 2. Options are 5 pi by 6, 5 pi by 12, 7 pi by 12 and 2 pi by 3. So we have with us secant inverse of 7 minus 5 of x square plus 3 upon 2 into x square plus 2. So I can write this as secant inverse of minus 5 by 2 plus 1 upon x square plus 2. Now I know that x square plus 2 is greater than equal to 2 for all x belongs to R. So I can also say that 1 upon x square plus 2 will be less than equal to 1 by 2. So minus 5 by 2 plus 1 upon x square plus 2 will be less than equal to 1 by 2 minus 5 by 2. So we have minus 5 by 2 1 plus 1 upon x square plus 2 less than equal to minus 2. So I can say that this particular function will have maximum value as secant inverse minus 2. Maximum value will be secant inverse minus 2. Now secant inverse minus 2 is pi minus secant inverse of 2, that is pi minus pi by 3 is equal to 2 pi by 3. So the correct option is D. Next question. Number of ordered pairs AB from the set A 1 2 3 4 5 so that the function fx is equal to x cube by 3 plus ax square by 2 plus bx plus 10 is an injective mapping for all x belongs to R. Options are A 13, B 14, C 15, D 16. Now what is injective mapping? Injective mapping means 1 1. Injective means 1 1. Injective means 1 1. So I have to check whether the function is 1 1 or not. I mean, I have to count the number of ordered pairs AB for which this function fx will be 1 1. So for that, let us first differentiate f dash x. So f dash x will become x cube by 3. So it becomes 3x square by 3 plus 2ax by 2 plus b, that is equal to x square plus ax plus b. Now for injective mapping, the f dash x should be always increasing or decreasing. Here I can see that the coefficient of x square is positive. Coefficient of x square is positive, hence this parabolic function should be always positive in order to make the function fx to be injective. So if f dash x is positive for all x, then this should be the condition that d should be less than 0. D should be less than 0, less than equal to 0. So D is a square minus 4b, should be less than equal to 0. Now if I put a is equal to 1, I have to pick values of a and b from this here itself. So how many values of b can we expect? B can be from 1 to 5. 1 to 5. Okay, because for all these values we will get a square minus b to be negative or equal to 0. For a is equal to 2, b will be from 2 to 5. 1 to 5, because at a is equal to 2 it will become 4, and for b is equal to 1 this will be also 4. So 4 minus 4 will be equal to 0. Hence for a is equal to 2, b will be 0 to 5. So in this first case, number of ordered pairs will be how much? Number of ordered pairs will be 5, and in this case the ordered pairs will be also 5. So for a is equal to 3, b will be from b cannot be 1, because at b is equal to 1, we get 9 minus 4, that is 5, that is not negative. For b is equal to 2, we get 9 minus 8, that is also positive. Hence b will be from 3 to 5. So the number of ordered pairs will be 3, 3, 4 and 5. For a is equal to 4, b will be from 4 comma 5. So the number of ordered pairs will be 2. For a is equal to 5, we do not have any values of b. So now we count the number of ordered pairs. 5 plus 5 plus 3 plus 2. So 5 plus 5 plus 3 plus 2, that is 15. Hence the correct option is C. Let a be the greatest value of the function fx is equal to log base x greatest integer x. This denotes the greatest integer x function. And b be the least value of the function gx is equal to mod sin x plus mod cos x. Then a is greater than b, a is less than b, a is equal to b, 2a plus b is equal to 4. So now we see we have fx is equal to log of greatest integer x plus upon base x. For x belongs to integer. Now first of all we need to find the domain. So x cannot be equal to 0 and x cannot be equal to 1. Also x cannot lie between 0 to 1. Not equal to 0, not equal. X cannot lie between 0 to 1. Why? Because for 0 to 1 the greatest integer of x is 0 and log 0 is not defined. So and x obviously cannot be negative. So x should be greater than 1. Okay, x should be greater than 1. So for integer values, when x is integer and x is equal to integer, we have f of x is equal to log x base x, that is equal to 1. And when x is not equal to integer, so for example x is equal to 2.5, so the greatest box of x will be 2, for 2.5 will be 2. So fx will be now equal to log 2 base 2.5. Here the base is greater than the argument log this 2. So we can say this lies between 0 to 1. This cannot be equal to 1. This is greater than 0 but less than 1. So the range for fx is 0 to 1. 0 to 1. And we want the greatest value of fx because a is the greatest value of fx. So a is equal to 1. Now gx was equal to mod of sin x plus mod of cos x. Okay, so for now let us find g of 0. G of 0 will be sin 0 will be 0, 0 plus cos 0 will be 1, 0 plus 1 will be 1. Now I can see that this is also positive, this is also positive because both are lying within mod. So and both can, so the least value should be 1. Why? Because when sine of x is 0, then cos of x won't be 0 at that same time, because since they are positive, so this to be 0, both of them should be 0, but both of them cannot be 0 at the same time. So this is the minimum value 1. And for g is equal to pi by 4, I get root 1 by root 2 plus 1 by root 2, that is 2 by root 2, that is root 2. Hence the range for gx is gx belongs to 1 to root 2, and b was the least value of gx, so b is equal to 1, so a is equal to b. This implies that a is equal to b. Hence the correct option is C, a is equal to b. Question: let a is equal to a to infinity denotes the domain, then f from a to infinity to b, fx is equal to 2x cube minus 3x square plus 6 will have an inverse for the smallest real value of a if a is equal to 1, b is equal to 5 to infinity, a is equal to 2, b is equal to 10 to infinity, a is equal to 0, b is equal to 6 to infinity, a is equal to minus 1, b is equal to 1 to infinity. So basically in the question it is asking that we have to find the values of a and b for which this function will have an inverse fx. So now for a function to have inverse, it should be bijective. It should be bijective. Bijective means both injective and surjective. That is both 1 1 and on 2. So basically we have to define the domain of fx such that it is both 1 1 and on 2, and also we have to find the corresponding range. So fx we have is equal to 2x cube minus 3x square plus 6. So f dash x is equal to 6x square minus 6x. Now this function to be injective, fx to be injective, f dash x should be positive. F dash x should be greater than equal to 0. This means that 6x square minus 6x should be greater than equal to 0. That means x square minus x should be greater than equal to 0. Now the critical points for this function is x is equal to 0 and 1. Now we see the graph. At minus infinity the function will approach minus infinity. At x equal to 0 fx will be 6, so the function will something come like this, and at x equal to 1 it will be like this. After x equal to 1 it will go above. This is at x equal to 1. So beyond x equal to 1 I can see the function is increasing. So x should belong to 1 to infinity. X should belong to 1 to infinity. This means that a is equal to 1. A is equal to 1. Now in this range fx is increasing, so the least value will be f of 1. F of 1 will be equal to 2 minus 3 plus 6, that is equal to 5, and the highest maximum value can be at infinity, that is infinity. So range is equal to 5 to infinity. So this is b. This is b. From 5 to infinity is b, and a is equal to 1. So the correct option is A.